Europa is the biggest moon of Jupiter, with a huge ocean beneath the surface. The satellite's water under a huge layer of ice does not freeze because of the hot core of Europa, which is heated by Jupiter's gravity. This became known in the early 2000s thanks to the Galileo probe, which detected marks of an electrically conductive liquid under the surface of Europa. It also discovered that the surface is made of ice and that it's one of the smoothest in the solar system. It might seem that this is where our knowledge ends, but this is not true. Over the past 20 years, and especially recently, we have learned a lot of exciting details about this distant satellite. We offer to ponder on some of them and reflect on to what degree this distant world can be alive. So Europa, also known as Jupiter 2, is the sixth moon of Jupiter, the smallest of the 4 Galilean satellites. It was discovered in 1610 by Galileo Galilei. Over the centuries, more and more comprehensive observations of Europe were made with telescopes, and since the 70s of the 20th century, with flying spacecraft. Europa is slightly smaller than the Moon. With a diameter of 3,122 kilometers, it is the 6th in size among satellites and the 15th among all objects in the solar system. It is the smallest of the Galilean satellites, yet the mass of Europa is greater than all known satellites in the solar system that are inferior in size combined. Its average density is very low, and this points to the fact that it consists mainly of silicate rocks and thus is similar in composition to the terrestrial planets. However, it's not a dead object. Even now, scientists indicate geysers, which eject large amounts of water into the atmosphere of Europe in the form of steam. It is known that water molecules emit certain frequencies of infrared light as they interact with solar radiation. This signal was captured by the Keck Observatory scientists who found it using the spectrograph. It was designed to measure the chemical composition of planets' atmospheres. The observations were held for 17 nights. During that period, the scientists detected one weak, yet clear water stream signal. The analysis of the data showed that the ejection of the water molecules on Europa occurred on the side visible from Jupiter. According to the researchers' calculations, the blowout was so powerful and it contained so much water that it could fill an Olympic pool in just several minutes. Water entered the atmosphere at a rate of about 2,360 liters per second. If the dwellers of Europe were in that stream, that would have been their last attraction. The good news is, those inhabitants who would manage not to be blown to the outer space would be very easy to find, as the surface of Europe is one of the flattest in the solar system. The tallest formations that can be found here are merely several hundred meters. If we take a close look at Europa's surface images, we will see signs of endogenous geological activity, such as lines, lenticles, bumps and pits, and the so-called Connemara chaos below the center. The high albedo of the satellite indicates that the surface of the ice is pretty clean and young. It is believed that the cleaner the ice on the surface of the icy satellites, the younger it is. Let's also pay attention to the plains. Smooth plains can be formed by the activity of cryovolcanoes, which erupt to the surface, filling areas with spreading and hardening water. From Europa's orbit, we can see a chaotic relief that has different geometric shapes. We can also observe areas which are dominated by lines and stripes, ridges, usually doubled, as well as impact craters. Their number is small. There are only 40 named craters over 5 kilometers in diameter, which suggests that the surface is relatively young, from 20 to 180 million years old. So Europe has high geological activity. The spectral analysis of the dark lines and spots of the structure shows presence of salts, magnesium sulfate in particular. The reddish hue allows to assume the presence of iron and sulfur compounds as well. Apparently, they are contained in the ocean of Europa and are ejected to the surface through clefts and then freeze. In addition, traces of hydrogen peroxide and strong acids were found. For instance, there is a high chance that Europa contains sulfuric acid hydrate. Let's land on that interesting object. As it turns out, it's not that easy. The thing is, Jupiter's moon Europa is surrounded by a region of sharp ice needles which stretches along the entire equator and is extremely dangerous for space probes to land on. Ice needles, also known as calgispores on Europa, can reach up to 15 meters in height. Large as they are, these structures still cannot be seen on the images of Europe available to us so far. A few careful maneuvers and we landed. Phew, we managed not to damage our spacecraft by this gigantic icicle. The incredible view of Europe opens to our eyes. Its surface is very cold compared to the Earth. The temperature here is 150–190 degrees Celsius below zero. But that is not the main thing to worry about here. The radiation level on Europe is extremely high, as the satellite's orbit passes through the powerful radiation belt of Jupiter. The daily dose of radiation here is nearly 1,000,000 times bigger than on Earth. This dose is enough to cause severe radiation sickness. But no worries, we have a proper radiation protection. At least we hope so. Well, with this in mind, we are sending a tunnel robot with a nuclear reactor into the deep of Europe that could drill ice while collecting ice and water samples and sending information to the surface via fiber optic cable. Surprisingly, Europe has several layers of ocean, separated by different types of ice formed at different depths and under different pressures. It is likely that in each of these layers, different life forms might be found. Species that have adapted to the particular conditions of the ocean stratum may exist. However, if these life forms turn out to be unlike anything we have seen on Earth, it might be difficult for us to recognize them. And besides, we might not find life there at all. But these thoughts wouldn't stop our curiosity, would they?